Hello, welcome to the chemistry revision. So in today's chemistry revision, we'll continue from where we ended. So here we have this question also which came in the same year, 2018. So this question reads, study the reaction scheme below. So we have black solid A. Then here they're saying reacted with the dilute sulfuric acid. Then here we have light blue solution B is produced. Then this light blue solution is produced plus liquid C. Then they're saying that reacted with sodium hydroxide followed by excess of it. Then light blue PPT, they're saying persist, PPT persist insoluble in excess, which is D now. So now this question is coming from the topic known as qualitative analysis. So qualitative analysis deals with the identification of ions of compounds. Okay. So now what happens here is this. In such a situation like this one, they're saying identify the black solid A and liquid C. So they need us to identify these two things here only. Okay. So if you have sulfuric acid, like you have black solid A, then that you react it with sulfuric acid like that. And then you get to form something like substance A, which is light blue. Plus then this liquid C. Then you need to know that the only thing that can react with sulfuric acid to give you a light blue substance or solution should be copper. All right, so this should be copper 2 oxide. It's the one, okay, which is reacting with this sulfuric acid. Then whenever these two reacts, okay, let me write it in a chemical formula. Copper, when they write copper 2 oxide, the symbol for copper is this Cu. Now when they put 2 here, they mean the valence of copper is 2. Then this oxide is oxygen. Then the valence for oxygen is actually 2 as well. All right, so these, when they cancel, they cross, they form like this 2 here and these 2 here. So 2 and 2 cancel. So this one just ends up to this, as this is the formula for copper oxide. So I will explain more when the right time comes to explain about the valence here. Okay, so now we'll put this copper oxide plus SO4 equals, then so these are reacting. So usually a metal will come and remove oxygen there, they will swap, and then once they do there, it will remove hydrogen. It will be like copper 2 sulfate. Okay, then plus this hydrogen and this, they will combine it to form H2O. So you see that this is the light blue substance here, which is this one. This is copper oxide. This is water, this liquid C. So this is B. So liquid C here is water, okay? Water. Then A here is this, okay? So here when they say identify the black solid A and liquid C, it is the black solid A is copper dioxide, then liquid C is water. So I'm actually annoyed with myself because this video that I'm recording, I recorded it in the morning, but couldn't. But because in my phone, I use my phone to record, because my laptop, when I use it to record the voice together with the app I'm using to record the screen, if I use my laptop entirely, then the noise comes out because the pen interferes with the sound. It's like they're not compatible, so it makes some noise. So now I record using my phone separately and the screen using my computer. Then I combine the two, the video and the audio. All right, and that's why the video sometimes takes time to come out. Now when I recorded, so it was in my phone, the audio, so I was about to put it on my PC to combine. Now I saw that in my phone there were other odd files that I had recorded and I've already uploaded, so I wanted to delete them. So as I was deleting them, I deleted, and then left like the one I had recorded. So when I connected my phone to the computer to remove it, to put it on the computer to combine it with the video, I ended up discovering that it wasn't there in the file. I came to my phone, it was there. I tried to share it, maybe using WhatsApp, to my phone, to my computer. It wasn't. It said it has been deleted. Then I said, but how? I decided I left this one with and it deleted. So I remembered that those files I was deleting, actually they were not actually even in there, because whenever I'm copying an audio from my phone on my piece, I cut it. So those were just like image. So when I was deleting those like images, I ended up deleting my original or my current recording. So I tried to recover it using different apps. It couldn't work. So this has now hit me because I'm doing this work for the second time, which means that I'll be unable to do other things because of time. So I'm really hurt for that. So I just wanted to make you know that sometimes we go through a lot as content creators. So 7.8, this question says 7.8 grams of pure zinc metal was reacted with the 100 cubic centimeters of 2.0 moles per cubic decimeter hydrochloric acid. Which one of the following two substances was a limiting reagent, reactant in excess, and correct formula for products? Okay, so the question is quite clear. You are told 7.8 gram of pure zinc metal was reacted with 100 cubic centimeters a of the language they use sounds ambiguous when reading it. 100 cubic centimeters of this one of 2.0 more per cubic decimeter hydrochloric acid. So this was reacted with 100 grams of 2.0 more cubic decimeter hydrochloric acid. So now the question they're saying, which one of the two substances, like pure zinc metal was, and what, and this one hydrochloric acid. Hey, what is going on? Yeah, hydrochloric acid was a limiting limiting reagent. Okay, then they say reactant in excess. So when you are using reagent, be consistent, guys. These are one and the same thing. Reactant, yeah, that we normally use. If we are using the word reagent, we go ahead with reagent. Now they are changing. It should be when they say which one of the two substances was a limiting reagent, then here they should have gone reagent in excess. Now they change reactant in excess and correct formula for products. This makes reading so hard because your brain registers this. Again, it starts registering a new thing. This, if we are using reactant, we should go ahead with reactant, not we start swapping them as if they're different. No. So anyway, that is sad, but we can answer this question. So now when you look at the option, we have and the correct formula of for products. So first of all, what they are saying is this, like you have zinc metal. So like zinc metal here is reacting with hydrochloric acid to give you zinc chloride like that plus plus hydrogen gas. Okay, so that's what is going on because this is displacing, this zinc is coming here to displace the hydrogen gas. Okay, then the hydrogen gas comes out there. Okay, as hydrogen gas, then when it joins itself here, it forms zinc chloride. Okay, so then here hydrogen gas is H2. Then others they'll say, but there was one. So they'll say, but there was one. So they are thinking it can be like this. Then zinc like that. Then like that. This is totally wrong. This is not true. Totally wrong. This science will not learn it anyway. So this one is going to have a 2. Where does it come from? Remember, this is a chemical formula of zinc chloride. So we use valences. So zinc has a valence of 2, then chlorine has a valence of 1. Okay, so whenever they're reacting, you'd find that with the two valences of chlorine, these are valence electrons, actually electrons which are lost. So with the 2 electrons of zinc, there are 2 atoms of chlorine that needs those 2 for each one of these 2 to become stable. So now in such a case, we just know, okay, the valence of zinc is 2, the valence of chlorine is 1. So here they're going to swap like this, so that this one can become like 1, this one comes here. Okay, let me do like this. Yeah, I want to get a highlight, I think, so that it can assist me to highlight certain things, to locate where the mouse is going to be. Where is that highlight I'm using? Okay, I can't see it. Where is it? Oh, it appears those apps that I installed, which I was trying to use to recover my, oh, it's here. I didn't remove. Okay, it has come. So this one will help me to locate. Okay, so now, yeah, so this one comes here. Then you write the chlorine. Then this 2 comes down here. Now this one is never indicated, so it just becomes zinc, then chlorine 2. Then why we have hydrogen 2 here is because hydrogen in nature does not exist like this. Like in the air, if hydrogen is in the air, it will not exist like this. Okay, oh no, it will not exist like this, it will exist like this. Okay, this is hydrogen gas. This is the how hydrogen gas is in the air. So guys, you may hear my sound is so slow. Yeah, I'm using a low voice so that I don't speak very much. The more I speak like with high voice, the more the cough comes. So I just want to do these things, you know. You people want to write, and also I am not that much feeling better. So if I don't do this, who is going to do it? So let me just go ahead and do it. You know, we collected the money already, so we need to do this. So again, so yeah, I wanted to just say that. So this is the equation. So having this equation, you need to balance it first of all. Maybe let me write it here so that I'll work with it well. Okay, even here. So I check here. So the zinc metal is one atom here of zinc metal. Here is one. So zinc is okay. Hydrogen here is one. Here the two. So I'm going to put it to here. So now chlorine is there two. Because of these two, here also chlorine is there already two. So this equation is now balanced. So now, when now it comes to this question now, when it says which one of the two substances was a limiting reagent, reactant in excess, and correct formula for the product, now we first have to know we were provided 7.8 grams of zinc, 7.8 grams of pure zinc, and then we are provided 100 cubic centimeters and of the same hydrochloric acid and 2.0 more per cubic decimeter. So for us to know which one of these is a uh, is a is a limiting reagent, first of all you need to understand what a limiting reagent is. A limiting reagent is a reagent or reactant that is in less supply when two things are reacting. Okay, so first of all you must understand that like the way we have zinc and hydrochloric acid, these two are what we call reactant. Two things that are coming to react. All right, so let's be good in English, guys. So to react, because why I'm saying so, usually we discover that when we are teaching, people are not understanding the English. So if you are not understanding the English, then it's not that science is hard, it's just that it's the English you are not just understanding. Okay, so just be good in English. I think the science will be easy, because such terms like reagent, reactant, even in English, they're just normal words, I think. Yeah. So I'm saying so because I want to connect. So reagent or reactant are two things that come together, all right, to react. Then the products are the things that are formed after reaction. Now they are what we call limiting reagent and then reactant in excess or reagent in excess. So between this one and this one, there can be one, a limiting reagent, another one, an excess reagent. So what does that mean? A limiting reagent is one of these that has been provided in a small amount, such that when the two of them react, that one which has been provided in less amount finishes, while the other one that has been provided in more amount remains. The one that remains, we call it an excess reagent. All right, so that's what it is. Okay, I hope I've done the explanation there. Now, I will come to the question now. So for us to see which one is the limiting reagent and excess between this and this, we'll look at what have been provided. So what they have provided, we'll turn it into moles. So what we are going to do, we'll calculate the number of moles of zinc first. The formula for calculating number of moles when you are given mass of zinc is like number of moles should be equal to mass over molar mass. Okay, then you say equals, so mass is 7.8, then over you get molar mass for zinc. So like if I were to go to the periodic table and check zinc, so you'll see that zinc will have the mass, molar mass is equal to atomic mass here, 65. This is zinc, 65. So we'll just come and say, okay, it is now going to be 65. Okay, so then we'll divide this 7.80 by 65. Okay, so now I'm just going to do that. So I'll say 7.8 divided by 65. I'm going to get 0.12. So 0.12. So these are the moles of zinc, okay, which have been now provided. So I'm saying I'm calculating to see which one will be more. Now we'll also calculate the moles of hydrochloric acid now, because we are provided volume and concentration, meaning the number of moles here will change. So we use the concentration formula, which says concentration is equal to number of moles over volume. Now what we want is, because here we found the number of moles, even here we need the number of moles, so we'll get this to be the subject of the formula, which will mean the number of moles will be equal to concentration times volume. So which will be equal to concentration, we are provided 2.0 mole per cubic decimeter. This is concentration, so we'll write 2 then times, then volume is this one here, so it will be 100. Okay, now volume is not supposed to be in centimeter cubed, it's supposed to be in cubic decimeter, so we convert it by dividing by 100 here. So by putting this 100 here, I've already converted it intelligently. All right, so now what we are now going to do here is just to do like this. We'll just say 202. Okay, we'll just say 2 times 100, it will be just 200. Okay, 200. Then we are dividing by 1000, so dividing by 1000. Okay, so this one becomes 0.2. So here the number of moles will be 0.2 moles. Now these are the moles that have been provided. Now we need to see of the moles that have been provided which one is the limiting reagent, how much of this will be used, okay, and how much of that will be used from the balance equation. So from the balance equation, usually you just say number of moles of zinc using stoichiometry over 1, you're going to say is equal to number of moles of hydrochloric acid, okay, like that, over 2. So this one is coming from the front of this zinc here, there's nothing there, so N stands for number of moles of zinc over 1, the stoichiometric coefficient here, then equals, when I say equals, it just means that other books they will just put like this. Okay, maybe let me just do this instead of saying equals, then I'm just going to say, okay, I'll just say to this. So this one and this one are reacting. So this one to this one. So like hydrochloric acid, number of moles of hydrochloric acid over the coefficient here is 2. Okay, now we are provided number of moles of zinc are the one we calculated here. So we'll substitute here 0.12 moles over 1, then we'll do like this, the number of moles of hydrochloric acid are the one we have found here, so we'll just put it 0.2 moles divided by 2. So when we divide the 0.12 more divided by 1, it is going to give us the same as 0.12 moles, then 2, then here when we divide this, I'm sure it is going to give us something like 0.1 moles. So we are going now to to look at it. Now this means that of what we are provided, like here, the reaction, this is what it is going to use all of it. Okay, so all of them, they will be used, the moles of zinc that have been provided, they'll be used in the reaction, because this is coming from the reaction relationship But here again, we are told from here, like here, the reaction out of the 0.2 moles of uh, hydrochloric acid that were provided, only 0.1 will be used. So in such case, if only 0.1 will be used, but you provided this, it means this is in excess. All right, so this is in excess, then this is limiting, this is in excess. So in this case now, we are going to conclude that the hydrochloric acid is in excess. Yeah, it's making sense. It's in excess. So since hydrochloric acid is in excess, um, because this is what was provided, this is what the reaction would do use. So it is in excess hydrochloric acid. So which one is the limiting reagent then? This one, zinc is the limiting reagent in such a case. So now, since in our question they're asking us to say which one of the two substances was a limiting reagent, so we have found it, this one. So limiting reagent, it should be hydrochloric. Oh, limiting reagent should be zinc. So it's this one here or this one here. Then here, reactant in excess, we have said it is hydrochloric acid. So reactant in excess, hydrochloric acid. So this one qualifies, not this one. Okay. Then, and correct the formula of products. So we have seen that the formula for the product is this one, zinc chloride, which is this, and hydrogen gas, which is this. So here the answer is that. Okay. So now we come to A8, which says how many moles of oxygen gas would occupy a volume of 1,200 cubic centimeters at room temperature and pressure. Okay, so now let me just clear this calculation here, guys. I have space. Okay, so let me do this. I know here the answer I had to put this. So now here they're saying how many moles of oxygen gas. Okay, so we are dealing with oxygen gas would occupy a volume of 1,200 cubic centimeters at room temperature and pressure. All right, so this is a simple question. So let me show you why this one is a simple question. So we'll just come to the periodic table and take note of something important. So let's just do this. Come here. Let's read here. It says the volume of 1 mole of any gas is 24 cubic decimeter at room temperature and pressure. So what are you getting? The volume of 1 mole of any gas is 24 cubic decimeter at what? Room temperature and the pressure. So see how I'm going to use this information. I'm going to say 1 mole of a gas will be equal to 24 cubic decimeter at what? RTP. This is what is in this statement, guys. This is in what is in this statement, which is here. 1 mole is equal to 24 cubic decimeter at RTP. That's that. That's that. So now, but in this case, they're saying how many moles? They want moles of oxygen gas would how many moles of oxygen gas would occupy a volume of that. Here they have been provided a volume, but at still room temperature and pressure. So they still want at RTB. So in this case, you just put, oh, you have been given 1,200 cubic centimeters. So convert it into decimeter. You divide by 1,000. All right. So that these cancel. So you have 10 into 12, which will be 1.2. So meaning you have like here the volume of 1.2 cubic decimeter. Now, like they want moles this side, so you say X, you don't know. So how do I come out quickly to arrange them like that? Because the moment I figure out the first one, the second one becomes automatic. If I'm given more volume, then I'm asked moles. Then I'll just, like when I change this one into cubic decimeter, okay? So now in cubic decimeter, I'm just picking this one here, picking this and putting it where there's also volume, and also where I'm asking moles, I put X. Then I just cross multiply. So this times that I'll get like 24 um, decimeter cubed. Then I'll say equals. Then I'll say this times this. I'll just say 1.2 decimeter cubed more. Okay, so this, then I want oh, here there will be X, so I want X, so I'll divide by 24 decimeter cubed. Then here I'll divide by also 24 decimeter cubed. So this one and this one will cancel totally, so I remain with X. Then I'll this one also and this one will cancel totally, so that I'll remain with 1.2 divided by 24. So if I pick my calculator quickly, so I'll say 1.2 divided by 24, I'll just get like 0.05. So I'll come and get 0.05. Now what is remaining here is more. Okay, so this is the number of moles that are in that will occupy that volume. So when we compare here, our answer becomes A. Okay, so we move to the next one. So this one says B3. It came in the same year, I think. B3 says, in chemistry, substances are classified as elements or compounds. Okay, so in chemistry, substances are classified as elements or compounds. Then here they say distinguish an element from a compound. All right, so this is an easy. You say an element, an element, an element is a substance made up of this of same type of atoms, while a compound is a substance made up of two or more uh, more two or more atoms, more atoms, more atoms of different substances. Okay, so that's how it is. So an element is made up of the same type of atoms, while a compound is made up of two or more different of is made up of two or more atoms of different substances. So like when I talk of copper element, which is written like copper, it's like this, but its symbol on the periodic table is Cu like this. So if you have a sheet of copper metal, in it there will be just small atoms, the same small copper atoms bonded together to form the big sheet of copper. However, if I have a stone of calcium carbonate, it will contain three elements in it. There will be calcium. This is calcium. Okay. Then there will be carbon. Okay. then there will be also oxygen. So meaning in that limestone you have, or calcium carbonate, a rock, that there'll be actually three types of elements: one, two, three. So it's a compound rock. Okay, so that's how you can differentiate these two things. Now we come to this question on B, which says the table below shows the chemical formula of some substances. So we have the chemical formula of some substances, which are like here, serial number, here 1, 2, 3. Then substances, we have, this is ammonia. Okay, so this is ammonia, guys. This is the ammonia, you should know it. Then this one is hydrogen gas. Then this is sulfur dioxide. Then this one is oxygen gas. Then when we read this question, which says from the table above, classify the substances into elements and compounds. So we will discover that those which should be compounds must agree with this other definition of the compounds, and those which will be elements must agree with the first definition of the element. So like this one, there are two elements here. There's nitrogen and hydrogen. So this one is a compound. So we will put it here, NH3, and the other one we have is this one, which contains sulfur and the oxygen. So, and the S2. Then these they contain the same atoms that are bonded. Those, they just become elemental gases. So we have this one, H2 and the O2. These are elemental gases. So we have classified. So then we come to this question B2. I think this question we even tackled it partially, because one of you guys sent it to me. That's why sometimes I don't solve most questions when some people ask them, because I always say that I'm going to cover them in my revision. All right. So now let me do this. So here what we are going to do is this. So here it says B form, study the reaction scheme below. So we are given dilute sulfuric acid, meaning reacted upon. When they put an arrow like that, then this is above. They are saying it is reacted upon by magnesium metal to produce salt A and gas B. All right. Then before we even go any further, we need to understand the general equation happening here. So here, like, you have an acid. Okay, this is like a general equation: an acid and a metal. So if you have an acid and reacting with a metal, what products are formed? So now what is formed, what we call metal salt. Okay, a metal salt is what is formed, plus hydrogen gas. Okay, so guys, you need to know this. So now in this case, you are given which acid, this one here, H2 SCO4 sulfuric acid. Then which metal do you have? You have magnesium. Magnesium, the symbol is Mg from the periodic table. So if these two react, so these are displacement reactions. So like magnesium comes to displace the hydrogen from the acid. So it will stay there as magnesium now, and sulfate ion like that. Then this hydrogen will come out as the H2 like that. Okay, so now so this is it, guys. So here, a part 1, when they say identify substances A and B, so like substances A, when you check here, this salt A, it's this magnesium sulfate. So you say magnesium. Okay, magnesium sulfate. Then this one, like gas B is just hydrogen gas. Okay, then we come to part 2. They're saying magnesium sulfate is an ionic compound. Write the chemical formula of all the ions that form magnesium sulfate. So the ions here is just this one here. This one, the ion that are there is just this one, magnesium, which is plus, okay, and this sulfate here, which is SO4, like this, okay. Then someone may say, but sir, how have you known that it should be like this? This is how it is, guys. This is how it is, because it is all emanating from the fact that valence electrons are the one we use to make formula, okay. So for this to have been existing like this, magnesium always, its charge is +2. I think there's a question where I'm going to explain this. I'm just reserving that so that I don't get to explain the same thing over and over again to avoid the video being long. All right. So now, what I'm saying, the valence for magnesium is always 2. So that 2 becomes its charge and ion. And this sulfur. Sulfur is a radical, and these radicals, we covered them in grade 10, and they always have a charge of 2, -2. Okay, so these are the ions that are there, guys. These are the ions which are there. Then they say, write a balanced chemical equation showing state symbols for the reaction between magnesium and dilute sulfuric acid. Okay, so here, again, this is again so simple, all right? So now, why I say this is simple, because when you check here, they are saying we write the balanced chemical equation, but they're saying showing state symbols. So whenever you are reading, you'll be answering exam. Pay attention to details, guys. Science is about detail. This is how science differs from other subjects. It's science is like what's this? You are a doctor, you are operating someone, and then you are not careful, you may kill someone. So people who don't become careful when they're doing science, they don't kill someone, they kill themselves, they fail the exam, because science has to be care has to be paid attention when you are answering it. So when they say, write a balanced chemical equation showing state symbols, meaning these two marks that I've given you, one is for showing state symbols, then the other one is for writing the balanced chemical equation. Now, usually when they say showing state symbols, they add 3 marks, but there's a reason why they've just put 2 marks, which I'm going to show you. So the balanced equation they want is this one here. So like this, like a sulfuric acid, okay, which is like this SO4. Now, you know, sulfuric acid is in a liquid form, so it is a substance that is formed when sulfur, for instance, dissolves in water, sulfur dioxide, and other things. So they form a solution, and then this one becomes aqueous. So now there are 3 states of matter we use, like in equation, 3 state symbols we use. I mean, in chemistry, we have like liquid, okay, which is represented by L for water, and then we have aqueous. I think aqueous, the spellings are quite ambiguous, which is represented by that, and then um, we have solid, okay, which is represented by S, and then we have gas, which is represented by G. So this is aqueous, meaning something was dissolved in water, not water alone. So now plus, this zinc is a metal, so I mean magnesium. So you write magnesium as a metal, and then it is a metal, so it should be automatically be in solid, represented by S. So you put like S like that, then plus, what else? Plus, oh no, why am I putting plus? So shouldn't be plus. So now this one is going to be like this, like magnesium. Okay, oh, it's already there. Sorry, magnesium sulfate. So again, this one, since it is going to form hydrogen gas, but this one always stays in aqueous, so it will be in aqueous, like there will be some watery things there. then plus then hydrogen. This one it is a gas, so there will be G. So this is a K2, guys. All right. Then since we are dealing with a balance equation, now check if that we to balance the equation by comparing the atoms on both sides of the arrow. Like hydrogen, how many are they here? There two. Then we'll move all the way to the other side and check how many hydrogen are here. There are two, so they are balanced. We'll come to this S, which is sulfur. How many are they? It's just one. Then when we come here, also check that sulfur is also one. Then when we come here, oxygen is 4. Then we come on the other side, we just say oxygen is 4. Then when we come here, magnesium is 1. We come here, magnesium is 1. So it's like the equation is already self-balanced. And this is the reason they just put 2 marks here, because they know that this person will not do the work of balancing, because they will inspect it. And if they are clever, they will just do nothing. If they are not clever, they will start balancing something already balanced and get it wrong. Okay, so this is the question, the answer here. All right. So now we move to the next question here. Okay, so this next question says name the acid that is found in sour milk. So in sour milk we find what we call lactic acid. Okay, so this is what we find in sour milk. Then like question B5 says calcium oxide is produced by heating limestone following the reaction below. Okay, so there's calcium oxide that is produced by heating limestone following the reaction below. So you have, this is calcium carbonate, which is limestone. Okay, then that is heated to form calcium oxide. This one here, okay, this is calcium oxide plus carbon dioxide here. Then here they're saying determine the relative formula mass of calcium carbonate. Okay, so this is becomes so simple. Oh, sorry, what is going on now? So now this becomes determine the relative formula mass. We are still having that. How are we going to stop that? Okay. Okay, so now we are determining the relative formula mass of calcium carbonate. So calcium carbonate is like this, guys, like this. So the relative formula mass is the sum of the atomic masses of each of these atoms in this compound. So like this atom here, calcium, the atomic mass is 40. Okay, I showed you where to find it, okay, on the periodic table. Then for calcium, I mean carbon, it's 12, okay, and then for oxygen, it's 16. Now you total them. Sum means you total like 40 plus this one here 12, okay, then plus this is 16 here. Now 16, these oxygen atoms, there are 3 of them, so each of them is a 16, so we'll say 16 just times 3. Then now what we are going to do is to say 16 times 3, 3. So I'll multiply this times this, 18, carry 1. This times this, it will be like 3 plus 1, 48. Then I'll just start adding 12. Then I'll also add 40. Then I'll add them, like I'll have like 0, carry 1. This plus that, 4 plus that, 9 plus that, 10. So it will be 100. So this one will be 100. So I'll say therefore the relative formula mass is equal to 100. Okay, then this one says determine the mass of calcium oxide produced if a 400.0 gram of calcium carbonate is decomposed. So let me come here. I think I had to push it here. Yeah, so determine the mass of calcium oxide produced if 400.0 gram of calcium carbonate is decomposed fully. So meaning if we have the same equation, calcium oxide, then that is the one being decomposed to give calcium oxide. To decompose is to break down, guys. Okay, then they've told us that this is 400 grams is the one decomposing. And they're saying determine calcium oxide, like how much calcium will be produced after it decomposes. How much calcium oxide will be produced? We don't know. So as we don't know the calcium, so now what we are going to do to find it is, since we are just dealing with mass, we can make it simple. So just look at the this equation and balance it. So look at this equation. Calcium atom here one is okay. Oxygen here there. Sorry, this is supposed to be 3, and there's supposed to be a C here. Yeah, yeah. C A C O 3. Okay. Yeah. So calcium here one, carbon here one, then oxygen here 3, and here there are 3. 2 plus 1 plus these 2 here 3. So now the equation is balanced as it is. Now we want to find how much of calcium oxide will be produced, and we're saying it's X. So we use this balance equation to find the answer to this, because we'll look at the more relationship in this equation, or the stoichiometric masses, molar masses of calcium and calcium oxide that will react, of calcium carbonate and calcium oxide, which will react here in this reaction, the one that are provided in this reaction. So here we have known that the molar mass, or for the whole of this, which is related to formula mass, is 100, as we have already calculated this side behind. Then here for calcium oxide, calcium is here. We are doing calcium oxide. Calcium is 14, oxygen is 16. If you add this, you find that it will be 56. Okay, this plus this 56. So here you have 56. So in the equation, that's what you are provided for. So this goes with that. Now how about that? You don't know, so you just cross multiply. So say 100 times x, it will be 100 x equals, then this times that. Okay, so just get a calculator where so we'll pick our calculator and multiply to say 400 times 56 and get 22,400. All right, so it will be 22,400 plus this gram here to come here. Then we want x, not 100, so divide by 100 to, and here 100 to remain with x. So this 100 and this will cancel, remain with x is equal to, so this 0 and this 0 will just cancel, so we'll remain with 2. 1 into that, it will just be the same, 224. Then the gram will come here. So say therefore 224 gram of calcium oxide will be produced. Okay, that's all. Then here you come to see, give one natural and one artificial use of the gas produced in the reaction above. Sorry guys. Yeah. So here say give one natural and one artificial use of the gas produced in the reaction above. So natural use of the gas, this is the gas here, carbon dioxide, it is used in photosynthesis. Okay, so it is used in photosynthesis by plants to manufacture their food. With water. Anyway, don't go into details like this. Even them just giving this line here, it's just wastage of space, because if you say give one use, you are just mentioning the use. So here, like artificial use, it's used in a fire extinguisher, so you say in fire extinguisher. Extinguishers also were in carbonated drinks. Okay, in carbonated drinks. Yeah, these are basically the common one. So let's see this other question we have here. This came in 2018 on the 17th of August 5. How many elements and atoms are there in a molecule of ammonium phosphate, which is this one here? How many elements and atoms are there in a molecule of ammonium phosphate? This one here. So now, how many elements? We'll start with elements. So how many elements are here? So we'll check elements. There's nitrogen, hydrogen, phosphorus, oxygen. So there are 4 elements here. Then we'll come to atoms, like total number of atoms. How many atoms are here? So like for nitrogen, because of these 3 outside the equation, the brackets, I mean, so nitrogen, there are 3 atoms already. Hydrogen, because of this 4 and this 3, so 4 times the 3, it will be 12. So hydrogen, there are 12. Then phosphorus, this P, they are just 1. So phosphorus P, just 1. And then oxygen of this, there are 4. So oxygen, there are 4. Yeah. Then we'll add this plus 3, 15, 16, plus 4, which will be 20. So there will be 20 atoms and then 4 elements. We'll come here. Number of elements, they're supposed to be 4, either this one or this one. Number of atoms, this one. So the answer is this. Then we come to question 6. The table below lists the data obtained in a titration experiment. All right, so titration is a qualitative analysis, okay, or is a way of determining the amount, the concentration of okay, is a volumetric analysis, I think, that is used to determine the unknown concentration using standard using standard solution. So a standard solution is a solution whose concentration is known. So yeah, so this is titration. So in titration, it is just so simple. For instance, if you have 2 substances that are reacting, like an acid reacting with a base, these 2, when they react, they may form a salt, okay, and water. That's what we know. So now in one of these 2, they can decide to choose either of these to be a standard solution. Like if A is a standard solution, then you must know both the volume. They will say, okay, this is 20 millimeters. You are provided 20 millimeters, and this is 0.2 molarity, meaning concentration. Then here they may just provide you with volume, or you may find the volume of this. Also maybe here it will be 15, okay, milliliters. Then here the concentration is not given. Okay, then maybe the question will be like, oh, now your job will be to find the concentration. So that is how titration actually works. So now this one is just so simple, because in each case you just need to know the number of moles. Okay, like you can know the number of moles of an acid, like, okay, number of moles of an acid can be found by concentration times what. Now before I do that, in such a case, what we know is that using stoichiometrically, the number of moles of an acid over 1, because we are assuming there's a coefficient of 1 here, is is also equal to the number of moles of the base over 1 this side here. That's how it is. But we know that the number of moles of an acid can be given by the concentration of an acid times the volume of an acid. Also, the number of moles of a base, these ones can be given by the concentration of the base times the volume of a base. So now, having this data, you can actually change this equation so that where there's number of moles here you replace it with that, so it becomes like that. Okay, times VA over 1, then equals, then here also where there's this one, you replace with that. Okay, times that of 1. So this is what it can be. Now, if this is what it can be in such a situation like this one, what now you can do, like here, if you concentration of the base you don't know it, it's simple. You just pick, like for the acid, the volume you put there, the concentration you put there, then for the base side, the volume there, you put this one there, then this one you don't know is the one you find. So you find that is titration, guys. This is titration. People think it's hard. Never, 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 never before. Now, so they're saying the table below lists the data obtained in a titration experiment. So trial, we have A, B, C, D, meaning they had 4 trials, A, B, C, D. Then volume of acid, or volume in cubic the centimeters. So in trial 1, they got 21.9, trial 2, 22.8, trial C, 22.9, then trial D, 23.0. Then here they ask us to say which reading A, B, C, or D on the table should not be included to compute the average volume of the acid uh, used in titration. Now, here, let me just clear out this information here. This is the answer we got. So here, what you must understand is that for titration to work out, to get these volumes, like those volumes I was showing you here, some of them are titrated using a pipe, are found using a burette. So like these are the ones. So they run the titration, like the reaction between an acid and a base. Like this, an acid was put in a burette, and then it was the one that was being reacted with the base. In this case, the base always stays in a conical flask, and then if this goes there in a conical flask, what happens is this: as the base goes to the conical flask, okay, the acid goes to the conical flask to neutralize. The moment it neutralizes, the volume of the acid that has neutralizes the base is taken. So like in the first instances, this is the volume which did. Then once they take that volume, they try to say, oh, maybe we did not notice the point at which the neutralization took place very well. So let's repeat the same process that we did. So they repeated the same process, they got this. The same process, they got this. The same process, they got this. Then when this question says which reading A, B, C, or D on the table should not be included to compute the average volume of the acid used in the titration. So here they want the volumes that they got that are inconsistent with each other. There's a term they use which I've just forgotten. Okay. That is not very important. So there's a term they use. So there's actually accuracy which is needed here. So values should be accurate if they're closer to each other. So the value that we should discard here is the one which is not close to each other. So it will be hard to notice here which value will not be closer to the other one. Okay, so let me first do this. Okay, so it will be hard for us to notice which one should we discard or should not include. So the best is to just consider these two values here. Okay, so when we consider this value here, this is 22, right? So 21, I mean. So now we only want to write 2 and 1, but before we write this one, we check the next number. The next number is greater than 4. So meaning we add a 1, we put 2. We get a 1 from 9, we put 2, 1, so that this one becomes 22. So this value becomes 22. Then this one also, we are going to write only this. But before we write 2, we check this number next to it, which is 8 more than 4. We get a 1, we add it to 2, it becomes 3. So this one between 3. This one, again, this is 22. But before we write it, we check the next number here, and meaning we borrow a 1, we put here to be 23. This one, it is already 23 because we will not borrow anything from this 0 to add here, so it will just be 23. So which values are close to each other? These are closer to each other, while this one is not close to these. It's far from these, so it's the one which will be discarded. So the answer is A. All right, which will not be included. Now we move. So we come to this question again, question 7, which says element X has 2 natural isotopes. The isotope with a relative mass number of 10 has a relative abundance of 20, while the other isotope with a mass number of 11 has a relative abundance of 8%. Find the mass number of element X. All right, so here the key concept is isotope here. So I am not going to write the definition because of time, because I want to end. You see, this video I did it again. Now I'm just doing it again. So I'm just stopping now to avoid it to be too long. So an isotope are atoms of the same element that have the same, I think let me write the definition because it will help the concept that I'm going to use. Otherwise, without it, I think it will not work. So an isotopes, okay, so we're going to say isotopes are atoms of the same elements that have the same atomic number but different mass numbers. Okay, so isotopes are atoms of the same elements that have the same atomic number but different mass number. So that's what atoms are. So what this means is this, atoms have got are represented always in this structure. Like here you can have Z, and here you can have A. So the number that exists here is atomic number. The number that exists here is mass number. Now we have atoms of the same element that can have the same atomic number but can have different mass numbers. E.g., examples I can give are isotopes of carbon. Carbon has got the element carbon we know. The element carbon that we know already to exist, carbon like this, carbon with the symbol like C, has got the 3 isotopes which are like we have the what we call the carbon 12 isotope, which is like this. Then we have also the other isotope, which is the carbon 13 isotope, okay, which is like this. And then we have also another one which we call the carbon 14 isotope, which is like this. So all these 3 are just isotopes, are all carbon atom, carbon atom, carbon atom. Now they have the same in similarity. They have the same atomic number these atomic number. Isotopes are atoms of the same element that have the same atomic number. So this is the why I wrote this definition to make you see what we mean. The same atomic number. Atomic number the same, atomic number the same, but different mass numbers. This is a mass number as I indicated. This is a mass number. Okay. So which stays here. So these are different mass numbers. So you see this is 13, 12, 13, 14. So this is how they are. So like carbon, like we know it exists in nature. There are three. However, when you go on the periodic table, you're only going to find one carbon, which is 6, 12 here. Okay, let me just show you now, you see, so that maybe you may think otherwise. So this is it. This is the carbon we are talking about. This one here. See, you're seeing 12, 6. Now the question can be, why do we have that? Okay, now we have that because there are calculations which we are done. So like if you picked any you know anything that contains carbon, carbon is found in, as human being, it's found in woods or trees. So if you picked a wood, okay, you picked a piece of it, wood, and you have a machine called the spectrometer that is used in science to determine this, you'd find that in that piece of wood, this is wood, okay, you find that there will be three isotopes of carbon of them that will make this thing. So there'll be maybe this percentage is for this carbon, this one here carbon 12, no, this one is in abundance, then this one maybe is here carbon um 13, then this bigger portion here, this bigger portion here, I've divided this one, right? So into 1, 2, 3. So this bigger portion here is for carbon 12. Now their amounts can either be determined in percentages. So they can either tell you this is 15, then here this is the 20, then here they say, okay, this is 65%. Okay, when you add all these, let me see if they'll give me 100, 65 plus 20 plus 15. So this is 0. Yeah, so 400. Yeah. Oh, sorry. So this is 100%. Yeah. So the abundance can be 15, 20, that. Now, there is a calculation they did in order to find what the average relative atomic mass for the carbon that they got and put on the periodic table. And when they put it on the periodic table, it's the one that represents all of these three. But however, the one on the periodic table resembles like this one. No, that one is not actually this one. It's just that the answer they found for the computation they did was similar to this. So it appears as if it is this one they picked. No, it's just not this one. Okay. So that one they calculated is the one which is found on the periodic table. And this is the question we are dealing with. This question we have here is telling us that element X has two natural isotopes. Here carbon has 1, 2, 3, but there is an element X. When they say element X, it means it does not even exist. It's just an assumption here. So element X has two natural isotopes. The isotope with a relative mass number of 10, okay, it has a relative mass number like this mass is number 1, has a relative mass number of 10, has a relative abundance of 20%, while the other isotope with a mass number of 11 has a relative abundance of 80. So this is the amount in percentage. Then they say find the mass number of element X. Like they find the one like on the periodic table, which one can they put between this? So they need to put to find the average. Now this is the formula that we use now. That's the one I'm going to put here. So atomic mass, relative atomic mass, which is a mass number, is going to be found by abundance. Okay, we say uh, atomic mass of element 1 times its percentage abundance, then plus uh, atomic mass of element 2 times its percentage abundance, then this is a summation of 2 then divided by 100. So this is how I do it. So this word here, this symbol here is a summation symbol, which means the sum. So in this case, we have two elements, this one and this one. So we have the first one, atomic mass, like we indicate this one. Atomic mass is this one. We'll put it there like 10 times. Then abundance, percentage abundance is this one here, like 20. Okay. Then plus, then we have the second one, atomic mass is this one, 11. Then times the percentage abundance is this one here. So it is 8, like that. Then we'll say over 100. Okay. So now, once you have this, you start evaluating. So this is what they did also with carbon, guys. Okay. So now what they going to do now, you get the, let me just do it quickly, like okay, let me send okay, this will be 200. Okay, this will be 200. So let's just say 11 times 8, that one there, plus 200, which will be that one, then divided by 100, which will be 10.8. So here the answer will be 10.8. So it has no units, so which means our answer is D. How have we moved to there? Good. Our answer is D. So let me end the revision here so that I start also doing something for biology and then prepare something for mathematics if the coffee is not going to go beyond. So guys, thank you for watching. But in the other revision, I think I went beyond this, but so sad that that audio got deleted, guys. So bye, see you in the next one.